Good morning, everyone, and warm welcome to this webinar about how to deploy massive IoT with wireless mesh. We're very happy to see so many of you joining this session today. My name is Youssef Kamel. I'm heading Wirepas Ecosystem Partners organization, and I'm very glad to introduce and moderate this webinar. So let's get started. With us today, we have Sebastien Pellorce, who's heading Wirepas Customer Success Team. He will walk us through the technology details. We also have Ben Corrado, who is heading Wirepas Americas, and will be available for any of your questions either during or after this presentation. I will shortly introduce Wirepas, then Sebastien will give an overview of Wirepas Mesh technology, and he will explain the main elements that enable massive scale deployments and simple installation. He will also introduce Wirepas positioning engine and network tool and provide a live demonstration of Wirepas mesh networks in action. We will conclude then by a Q&A session. So before we get started, a little bit of housekeeping. This webinar is expected to last 1 hour. It will be recorded and the recording will be sent to you automatically. The presentation will be available in PDF in the handouts section and on demand after the webinar. Feel free to ask any questions. We will try answering them during the Q&A section or even live. Of course, you can place your questions as shown to the right. It's pretty simple to just write down your questions and press enter. If we did not cover your question, and this morning actually we had a lot of questions that were not answered because a lot of traffic, please contact us. Our contact details will be shared at the end of the presentation. So now let's get started. Okay, so for those who don't know us, Wirepas is a Finnish company. We're headquartered in Tampere in Finland. And here's what Wirepas focuses on. First of all, the connectivity. Wirepas delivers reliable, optimized, scalable, and simple to use wireless mesh connectivity. This is delivered in software, which consists of the connectivity stack, open source reference software, and associated tools for diagnostics and positioning. But just to clarify, Wirepas do not produce or provide any hardware. We focus on delivering industrial grade mesh for massive IoT applications with high reliability and high performance. But of course, we don't do this alone. In the IoT, no company can deliver a full end-to-end solution to the end customers. So our go-to-market is very much consisting of building strong partnerships with our partners and ecosystem so that together with our partners, we can offer turnkey solutions to end customers. Wirepas Mesh is designed for massive IoT. It is high performance, easy to install and provision. It supports large scale and high density and is highly reliable. It also embeds low power positioning, but of course, I will let Sebastien soon give you all the internal secrets so you understand where the high performance comes from. The applications we focus on are logistics and asset tracking. This is a fast-growing area. It's actually booming today. And here, Wirepas delivers connectivity for location and end-to-end supply chain monitoring. Second application is smart lighting for industrial and commercial buildings, where reliability and low latency are key. The lighting systems use Wirepas for lighting control, but also the lighting infrastructure becomes a network to collect sensing data or people or asset location in the buildings. third pillar is industrial. Our customers and partners are using Wirepas to reliably monitor their systems for preventive maintenance and control. And last but not least, smart metering, where Wirepas is deployed in more than 2 million smart meters in Scandinavia. And we're now preparing the next generation smart metering deployments in emerging markets like India and Indonesia. Here's an overview of Wirepas Mesh and what we deliver. On the left side, you can see this green diamond that consists of the Wirepas Mesh stack. This is delivered as a binary that you can program to your radio device. Wirepas supports 2.4 gigahertz and sub-gigahertz bands and runs on multiple radio chipsets, namely the NRF52 series from Nordic and the EFR32 devices from Silicon Labs. Any device having Wirepas Mesh binary and the network credentials can join the network, establish upstream, downstream, and node-to-node communication, and extend the network coverage by acting as a router for other nodes. Wirepas Mesh is a decentralized network, which means that all networking decisions are taken by the nodes themselves. There's no specific routers, no network controllers, no networking tables, but of course, Sebastien will go through the details of what it means in practice and how this enables large-scale deployments. We provide an SDK that runs on the radio CPU for application development. We also provide a set of application examples for sensing and asset tracking to get you started. Wirepas Linux Gateway and Cloud APIs are available in open source through Wirepas GitHub. You can use them as is or customize them for your own needs. Wirepas also provides two cloud-based tools, the Wirepas Network Tool for network diagnostics, topology visualization, and network health monitoring. Sebastien will provide a demo of the tool. And also Wirepas Positioning Engine, which uses the mesh network information to provide indoor asset location. But of course, we don't do this alone. So Wirepas partners provide a wide range of sensors, tags, and gateway products, but also software tools and platforms around the Wirepas technology. I think it's now time for me to hand over to Sebastien for a further deep dive and demonstration of Wirepas Mesh.
Thank you, Youssef. Good morning, everyone. So I'm Sebastien. I will go through the presentation, I would say the technical presentation. We will cover different elements. We'll start by the Wirepas Mesh, looking a little bit more into the details about the technical advantages and basically how it works. We'll then cover the gateway and cloud APIs, and we will then finish by a live demonstration of our network tool so that you will be able to see two live network in action. Let's go to the core of the system now, the Wirepas Mesh. The first question is why Wirepas Mesh? And basically the answer to this question is fairly simple. Wirepas solve the traditional challenges of mesh network. Among other, the main challenges that has been seen so far are reliability at scale and density, and power consumption, especially power consumption of the routers, which usually requires mains power, and as a consequence are specific devices in the network. Wirepas Mesh solution delivers an industrial grade reliability with fit for purpose performance at large scale and high density, and with low installation and maintenance cost. So let's go now more into the details on those four pillars of the technology and look a little bit more about what is behind. But before that, let's have a look about how it works overall. The philosophy of Wirepas Mesh is that there is no network manager nor coordinator in the network. Instead, you just have devices, sensors, meters, luminaires, and a couple of gateways which are just acting as a bridge between this Wirepas Mesh network and any other internet connectivity via any backhaul. But those gateways, they don't have any specific role in the network except being a point of access to the external world, I would say. In Wirepas Mesh, we don't have any routing table, allowing infinite size of the network. The second very important element is what we call the decentralized operation. In Wirepas Mesh, any node can be a router, and the decision related to the network configuration, to the network topology, to how the traffic will get balanced across multiple gateways, multiple nodes, etc., is directly managed by devices themselves. Any device is able to be a router, especially because the power consumption of a router can be as low as 0.025 milliamps or 25 microamps. And this enables fully battery operated networks where all the devices are capable of being routers, and they will decide locally whether they are or not router at a specific time. Of course, on top of that, Wirepas Mesh support all communication direction. We can do uplink, downlink, unicast, multicast, and broadcast, as well as node-to-node communication. As a summary, the philosophy of Wirepas Mesh is simplicity. Why? Because devices are the network and the infrastructure is extremely slim and easy to deploy. Let's move now to the 4 pillars, and let's start by the industrial grade reliability. For each of those elements, I will present you 4 technological elements that explain how we can reach those different elements. So the first one is the self-healing and auto maintenance. In Wirepas Mesh network, because any device can be a router and because gateway are not coordinators of the network, there is no single point of failure. It means that in case a device got disconnected, in case a gateway got disconnected, or in case the backhaul, for example, the cellular is not up and running anymore, then the network will automatically reorganize to find alternate route, and this is fully automatic and fully managed by the stack itself. Any device being able to be a router, so any option is possible to connect and find an alternate route. In addition to that, the gateway being fully mutualized, then in case there is one gateway disconnected, another one will be able to take the relay. The second element is the reliability of the communication. Wirepas Mesh relies on a hop-by-hop acknowledgement and a specific means to send and receive data. We will see it after. But thanks to this acknowledgement, we are able to achieve a proven 99.9% SLA without having the complexity of end-to-end acknowledgement. Of course, in case a packet is not acknowledged, there is automatic retransmission built in the protocol. Third element is the security. Wirepas provides state-of-the-art security. We have encryption, which allows to encrypt both the signaling of the network as well as the payload. It means that an unauthorized party cannot join the network, modify messages, read message content, or replay a message. And finally, because we do RF, and because we most of the time operate in ISM band, so 2.4 gigahertz for the majority of the cases, but sometimes also sub-gigahertz, We minimize the impact to and from other. And this is thanks to a dynamic local channel selection, leading to a frequency agility among 40 channels, combined with a short time on air, listen before talk, and adaptive transmit power, which basically allow this protocol to be super efficient and minimize the spectrum usage, but also very resilient to other technology that might be present at the same place. For example, Wi-Fi, BLE, or other. We have also a local multi-channel interference avoidance, meaning that the nodes will automatically blacklist channels which are used by other radio in the area. That's for the industrial grade reliability. And thanks to that, we can basically deploy reliable network. But then what can we deploy exactly? The next element is fit for purpose performance. We have in Wirepas Mesh the capability to configure the devices and as a consequence the network in very different modes. The first mode is the low energy network, which basically enable infrastructure-less and fully battery operating networks where we can have years of battery lifetime with an automatic load balancing and bidirectional communication. In terms of performance, we have a router power consumption which can be as low as 25 microamps. So those numbers are given with a 2.4 gigahertz PHY. We can also further optimize for a non-router to be at 12 microamps. In terms of overall throughput we can get on the routers, it goes from 1.2 kilobit per second to 4.8 kilobit per second with a respective node-to-node latency from 8 to 2 seconds. The packet payload that you can send on Wirepas Mesh is 102 bytes. This is the payload you have for your application, including encryption and so on. This configuration is very interesting to deploy fully battery operated network of sensors, but sometimes you want to have more performance. That's not a problem because we can also configure the network to operate in high performance mode. In this case, we can achieve low latency and high throughput. By low latency, we mean sub 10 milliseconds per hop latency. By high throughput, we can go up to 32 kilobit per second per router with still a packet payload of 102 bytes. And unfortunately, but there is no miracles here, a power consumption that moves to 7 milliamps. But when it starts to be really interesting is because this configuration, which you may feel now on the screen as like a network configuration, is not a network configuration, but a device configuration. Meaning with Wirepas Mesh, you can support mixed mode network, combining low energy devices with high performance devices in the same network. And this enables the best, I would say, fit for purpose because you can decide to have, for example, low latency devices to control luminaires, and they are mains powered, so that's not a problem, but extend this network with sensors network, which can be fully battery operated. When we look at the gateway, Wirepas is a true multi-gateway network, meaning the gateway are fully mutualized. So more gateway just equal more throughput if we look at the performance. On top of that, we have a built-in load balancing, which allow to distribute the traffic across multiple gateways. The throughput of a gateway is roughly 120 kilobit per second, meaning the total network throughput you're gonna get is n times the number of gateways. Shall you want to deploy network which are non-connected, for example, for lighting application, Wirepas Mesh also supports gatewayless network, allowing to deploy non-connected system, which can be then connected just by adding a gateway because the devices will have the full protocol. So as you can see, the performance of the system is really scalable, going from ultra low power to high performance at device level. Let's move now to the large scale and high density, which are also two challenges which mesh network have traditionally seen because of inefficient spectrum usage. What is our answer to that? The first one is decentralized operation. That's the key feature of Wirepas Mesh. It allows any device to be a router at any time, and the node will self-organize themselves and dynamically promote who is a router, who is not a router at a given timing. We will see later on at the end on the WNT presentation live network, where you will be able to see real network and what is the topology we have. The second element to deal with large scale and high density is how efficient are you when you use the spectrum. Wirepas is a locally synchronized network. It means that any router will basically locally select, based on the local measurement, the best channel to operate. Among, for example, if we take the 2.4 gigahertz, among the 40 channels of the BLE which are available. On top of that, each router will have a local synchronization with its neighbors, meaning that all devices connected to a router will be allocated with a time slot, allowing to minimize the radio usage and to lower the power consumption, but also to increase the density because there are basically no collision, and we have an optimized peer-to-peer local communication thanks to the hop-by-hop acknowledgement we have seen before. So FDMA plus TDMA plus hop-by-hop acknowledgement, so that no collision, no repetition. Third element, short time on air. We use high data rate on the radio to minimize the time on air and answer to the density problem. The goal being to minimize the time we use a channel to maximize the number of devices we can put inside. And the last element, also related to the density, is adaptive TX power. Each node will automatically adjust its transmit power in order to minimize the power consumption, but also to maximize the spectrum usage in case of high density, because all the node will always try to minimize and limit as much as possible their impact on a given channel. All these combined together to give you one KPI allow us to achieve the capability to connect 1,000 devices in a cubical meter. This is a real test that we have in our lab. Our protocol is tested to reach this kind of performance level. So as we can see here, scale and density, and sometimes they are not linked together. You can have scale or high density, are basically achievable with Wirepas Mesh, and we have proven deployment, especially in the area, for example, of smart metering, where on the city of Oslo in Norway, we do connect 700,000 smart electricity meter in a single mesh network. I have now covered the real key elements of the mesh protocol itself. Let's now talk a little bit more about the installation and maintenance, which are also very important, especially if you want to move to large scale. We have two very important elements which I would like to present to you today, among others, but those are, I think, very important. The first one is the over-the-air update. Wirepas Mesh has a built-in over-the-air update inside the protocol, which basically allows any node to be updated via the network. When we say any node, it can be any node, but any part of the node, meaning we can update the Wirepas Mesh firmware or the application software. We have an efficient and secure mechanism to deploy the update image to indicate when all the nodes have received the update, to reliably trigger the command to update, to minimize or avoid any orphan in the network, and then to indicate that the update has been properly done. This is done in a secure manner as well, because all the firmware images are encrypted, and also this support multi-application, meaning if you have a network with different sensors, with different firmware, you can update one firmware or the other. The second very important element is provisioning. When you start to scale on large network, the installation cost, the provisioning, the configuration are usually becoming very complex. And here we have a very good answer. This feature is quite new. It's something we have recently launched as part of our Wirepas Mesh 5.0 release. And it allows basically a new node, what we call a joining node, to be able to establish a point-to-point communication with an existing node, a green node in the slide here. Thanks to this peer-to-peer communication, which is of course a limited connection, so the joining node does not have access to the network, the joining node does not have access to the credential of the network at that time, but through this peer-to-peer communication, this joining node can access a commissioning server, a provisioning server that could run either at the edge, for example, in the gateway, or in a specific server in the cloud. And this allows basically to have an end-to-end provisioning, the joining request going to the provisioning server, the provisioning server being able to identify whether this node is allowed to join the network or not, and if the node is allowed, send back via the mesh network and via the commissioning, the provisioning network for the last hop, sending this packet to the joining node, which will then take this into account, reboot, and connect to the network. So as you can see, you can super easily install new node without having to do any configuration on the node. That's fully automatic via the mesh network. Shall you want to do it differently with BLE, with NFC, or any other out-of-band provisioning, we do also support those solutions. That's the end of the first part of the presentation, which is related to the mesh network itself. As you can see, we have a technical answer for all those four elements I mentioned before: the reliability, the performance, the scale and density, and the installation and maintenance. Let's move now a little bit more on the gateway and on the gateway to cloud API. You have here a view about our Wirepas tool and cloud API. Wirepas provides on top of the protocol the Wirepas gateway reference driver. Those are fully available as open source component, and they provide a complete gateway to cloud API relying on MQTT and protocol buffer. This gateway, which is a simple Docker image that you can run on a Linux machine, basically support all the data flow, meaning if you add a sensor, you will be able to get the data at the MQTT broker level, but also embeds the configuration, the OTA for the update, and as well as the provisioning. If we look now more on the backend and on the server side, we have what we call the Wirepas backend, which is essentially made around an MQTT broker where we can connect the Wirepas network tool, which is a complete tool for network maintenance and monitoring, as well as configuration. And we can also connect the Wirepas positioning engine, which is an RTLS solver. This backend is again delivered as a set of Docker images and can run on any server, which could be cloud, or on-premise. The hosting being arranged by the end customer or the integrator. The user application, which is what Wirepas won't provide, but it's usually part of the final application, is usually directly connected to this MQTT broker. The Wirepas network tool, I won't spend a lot of time on this because you will get a live demo right after, but this supports built-in diagnostic coming from the nodes and allow to monitor, maintain, and visualize a mesh network in practice when the network is running. The second element where I'll spend a little bit more time because it will be less visible in the demo is the Wirepas positioning engine. This is an RTLS solver, fully leveraging the mesh network, which can be used to use the fully battery operated mesh network as a foundation to do asset tracking and indoor localization. The positioning engine is a stream-based processing engine, which converts essentially measurement made locally by the mobile tags to WGS84 GPS coordinates. This tool has an API, which is based either on MQTT or gRPC, and you can declare anchors, declare buildings, area, floor, zone, and of course, it will provide the tag position when a tag is sending a packet. At the end of the day, this combination of this mesh protocol software, this fully automatic network, those gateway to cloud API and tools makes Wirepas Mesh more than a mesh protocol. We talk now about a complete mesh solution for a wide range of applications. At the end of the technical presentation, I will now move quickly to the WNT demo. Before going to the demo, I will just give you a short description about where those networks are installed and what they are about, and then we will go to the tool. What is presented today is two live networks, which are two fully battery operated Wirepas Mesh network at two different locations. The first network is deployed in Finland in temporary area and is part of our test network that we have to test our release. This is an outdoor test network in 2.4 GHz. There is one gateway, 149 nodes, and we will see on the WNT that we exercise here a complex chain topology for the mesh. The second network is based in France. It's more about an indoor network for smart building application, where we have deployed two gateways, 42 nodes, and we do sensoring as well as asset tracking on multiple floors. The operation principle is exactly what we have seen before. Two networks, three gateways connected to one Wirepas backend, which is hosted in our own AWS infrastructure, onto which the PC application, which I will then use, is connected to. A couple of pictures about the deployment. So you can see here the first network. So we talk about those kind of small tags with triple A batteries inside, IP68, which are deployed outside. And for the second network, we talk about an indoor network where we have those kind of, again, small battery operated sensor, which are deployed inside a building. multiple floors, pretty old building, concrete in between the floors. Let's move now to the tool itself. You have here a view about the WNT, where I basically collect the information from those two networks and I'm able to visualize the mesh network. I'll start by the first menu where you can see a kind of dashboard of the different stuff. I can select my network, here the outdoor network with the gateway here, which are called sinks in our terminology, as well as the nodes with their different modes here. You can get information about the battery voltage, about the version of the firmware, maximum buffer usages, and link quality. You can then have this visualization of all nodes in the network, including all the information, again, about their mode of operation, their battery voltage, buffer usage, etc. Very interesting feature of this tool is that you can also see the topology of the mesh network. So this is just to show you that, yes, it's a mesh. And basically what we see here is one gateway, which is located here on the drawing, and then a set of nodes which are meshed together, some of them being on a fairly large chain topology, and this is basically what we exercise in this network. What is very important to highlight here is that this topology that you see now on the screen is not a static topology, it's fully dynamic. And if tomorrow we do a screenshot of the same network, the topology will most probably be different because the network automatically perform maintenance cycle at regular interval to find better configuration. I can then show the same view, so the link between devices, this time not on a topology view, but on a physical view, on a map, on an outdoor map, as you can see here, but I can also see it indoor. We will see it right after. So the mesh topology we were talking about is what you can see here. The network is basically in two parts. There is this mesh chain topology here, and we have another area, which is again with a chain topology where we have the gateway. So the gateway is located here. The network are meshed, the nodes, sorry, are meshed like this, and then this is the connection to the second view, which is the chain network. Let's take one node quite at the end of the chain. If I double click on a node, then I can see a lot of parameters related to the network itself. I won't go inside all parameters here, but I will just show you a few of them. You can get basically the number of hops in the network. So for example, this node has at the moment 38 hops to the gateway. I can also see the quality of the radio as well as the channel which is being used. So for example, here, this node is quite stable. You can see that is most of the time at the same frequency. We will see in the indoor network where we have more interferences that it's totally different. And the hop count is changing time to time between, let's say, 30 hop to 62 hop. What is very important is that this view, which is here a daily view, the backend includes the storing of the data. There is a database where you can see the data during time. I will now move to the second network, which is an indoor network. I won't go through all the details about the tool itself again. We will more focus on the result. Here I can do the same. I can see my map with my building. Here we have two buildings, a street in between, two gateways, one per building, and multi-floor inside the building. The nodes which are a little bit lighter in terms of color are basically the nodes which are connected in another floor. So I can go to the first floor, second floor, and basically for each of them, see my different nodes. I'll try to take another node and basically do the same as what we did before. And you can see here that the nodes are changing more often. The channel, it's an office building where we have a lot of interferences coming from Wi-Fi. So you can see here that during a certain period of time, the node have changed several times their channel. And if we look at the next hop address, so I will just find the parameter. So this is basically the next hop address, so to which router the node is connected to. And you can see that this is changing during the time, meaning that this node has changed its route to another router. Not necessarily changing the channel, which is normal. Let's have a look to the topology. A little bit different here. We have two gateways. The gateway are pretty far from each other and located in two different buildings. That's why you can see that there is not a huge load balancing which has been done between those two gateways. The idea of this test network is to say, okay, if one gateway got disconnected, the network should be able to cross this street in order to connect to the other gateway, at the cost, of course, of having very few nodes able to connect, but that is to maintain the service, I would say. Again, we can see the topology in hierarchy view, and again, nothing has been configured here. You can also compare the nodes, so you can query a comparison of the different nodes and, for example, check what is the average or the max buffer usage for numbers of nodes in order to identify potential node where there is significant traffic. In this network, you can see that this is right now pretty quiet. We still have a pretty low load on the network, but sometimes we can see higher traffic. And finally, we have a settings menu where you can configure the tool, but you can deploy updates. So you can use this tool to select a new update image and push it to the network. You can also configure your floor plan, configure your network, set the diagnostic interval, which is how often the node will send diagnostic information, which are used by this tool. And you can also control the different nodes so that you can place them easily on the map in case you want to change their position. Each time you change the position of the node here, that basically triggers the configuration of the Wirepas positioning engine, meaning that all those nodes here are used as anchor to localize mobile tag. If I go again to a node, you can see at the end here the different position of the anchor, which are being configured to the positioning engine, so that a mobile tag will get localized with the system. At the end of this presentation of WNT, this demonstration is basically available. So if you want to get access to this system, feel free to ask your sales contact and you can use this tool. I will now finish my presentation here. Thank you very much for your attention. I move back the mic to Youssef for the question and answer. Thank you.
Thank you very much, Sebastien. Thanks for this walkthrough of the technology and thanks for this demonstration. I hope you guys have enjoyed. So let's take a few minutes. We still have a few minutes to take some questions. There's been a very good traffic of questions. Thank you for participating. I think Ben has replied live and in writing to most of the questions actually. So I still will pick a couple of questions so that we can discuss them here. First one is, can you share some data point related to the throughput metrics on data transfer in a 200 device mesh using 2.4 gigahertz? So I think, Sebastien, you have already covered this in terms of the overall throughput of the network. We can support up to 150 kilobits per second for a given gateway. And of course, the traffic upstream will depend on the number of nodes in a given gateway. But for the typical case of for example, an over-the-air update for a 200 node network, usually this takes less than 10 minutes to transfer a 512 kilobytes of image across the network. And the reason for that is that for every channel, we will be able to have one copy happening, but since the network has 40 channels working simultaneously, then of course the copy time is actually divided by the number of channels. So in practice, it takes usually less than 10 minutes to download a 512K OTAP across a 200 node network. Second question is regarding the information about the location. So maybe Ben, if you want to clarify a little bit the way the location is actually implemented. So some people have referred to it as GPS. Some others have asked about AOA and AOD. Can you please say a few words about the Wirepas positioning engine?
Yeah, so the way the Wirepas positioning engine works is we actually take data from the nodes about their connections to other mesh nodes in the network, so anchor points. And we do a multilateration scheme with machine learning on top of that to be able to calculate where that is in an XYZ coordinate frame that's in reference to all of those anchors that are out there, which are other battery-powered Wirepas nodes that are in non-moving locations. And those anchors pass that data back using the mesh network that they form, and the end tags that you're tracking don't actually participate in the data routing. So that means they're free to roam the network quite liberally, and there's no impact to performance based on them moving, large amounts in short amounts of time. And then when you have all that data coming in and we process that either on premise in a Docker container or up in the cloud, the output of that is a GPS-like format. So what you get as the output is WGS84 encoded position, so latitude, longitude, and altitude. And then you can take that, and the reason we do it that way is you can put that into lots of mapping programs that already support GPS. So basically, if it supports a GPS format that comes out over MQTT already, integrating with our Wirepas positioning engine is pretty simple. So hopefully that answers those questions. If you have more, stick them in the questions and I'll try and clarify.
Thanks, Ben. There's still a last question maybe on the RTLS or WPE, Wirepas Positioning Engine system. What type of calibration process during installation is required for the Wirepas Positioning Engine outside the XYZ coordinates? Is there any calibration required?
No, that's it. So you basically place the node on a map or insert over an API its coordinates, and you either put in the API how many meters it is above your reference point, or in the map what floor it's on, and that's all you need to do. The system takes care of the rest.
Then another question on the versions of Wirepas Mesh. Since when the automatic provisioning feature is available in Wirepas Mesh?
Yes, that's a new 5.0 feature that we just released about a month and a half ago. So we're supporting that on 5.0 and forward.
Okay, and I think there's also a question regarding the power consumption. I think Sebastien has mentioned that a router node can consume as low as 25 microamps. The question is, what is the average and worst case power consumption for a battery operated router?
Right, so maybe I can answer this one.
Yes,
indeed,
please.
because it's a mesh, the closer you are from the gateway, the more traffic the nodes will have to route. But basically, what is very interesting in Wirepas Mesh is that because any device can be a router, the node will maximize the number of routers to absorb the traffic. In addition to that, we have bufferization in each node, meaning that if you have a peak of traffic, we can absorb. How does that translate to power consumption? I would say the power consumption will vary from a node without any traffic to a node with traffic. If we take the example of a 2.4 gigahertz network, that will basically move from 25 to, in general, 50 to 80 microamps, depending on the load of the network. The network is also able to automatically adjust what we call the access cycle. You have seen in the presentation latency, which are going from 8 seconds to 2 seconds. When moving from 8 to 2 seconds, that indeed increase the throughput of the network, for example, to absorb a peak of traffic, but that also increase a little bit the power consumption. So dynamically, the node may increase their mode to absorb traffic and consume a little bit more. But all that to say, we still are very, very, very far from the 7 milliamps, which is usually the power consumption of a router in a mesh network. We talk about maximum 100 microamps.
Thank you, Sebastien. Maybe I will take one last question here before wrapping up. There was a question on time on air. Can we elaborate how to optimize the time on air, or how the mesh network optimizes the time on air? Can you take this, Ben?
Sorry, I was typing another answer.
Yeah, the question is regarding time on air and how the mesh network optimizes time on air, because I think that was also mentioned by Sebastien.
Yeah, so in the low latency mode, the time on air is basically on demand, and in the low energy mode, those access cycles that Sebastien was talking about basically determine the how often a node sends data, and that automatically scales based on the solution that the network chooses. So based on the amount of traffic and the amount of demand going through, that access cycle will change anywhere from the 2 to 8 second range.
I think I will also take one last question before closing. Do you have any sort of support for connecting to BLE Mesh? Can we run Wirepas and BLE Mesh on the same device? Sebastien, would you like to take this one?
Sure, Youssef. So basically, we do have exactly the same physical layer as Bluetooth Low Energy. The reason being to be able, for example, to receive and transmit BLE beacons. So if we talk, for example, about asset tracking, any Wirepas tag can also send a beacon. Any Wirepas anchor can also send a beacon. For localization outside of the network coverage, but also for indoor wayfinding on other applications. The second advantage of being a same physical layer as BLE is that it slightly simplifies the certification of the product because we have exactly the same physical layer as BLE. So yes, we can interact with BLE devices, mainly using beaconing, either in transmit mode for any node, and also in reception, which is limited to high performance node for the simple reason that beacons are fully asynchronous.
Thank you very much. And I know there's been some questions that we did not cover here, and we will definitely answer to them. And please feel free to contact us. Maybe if we can show the next slide so that we can share a little bit the links, how you can contact us. There is a download section on the Wirepas website, which is www.wirepas.com/downloads. There's quite a lot of information there that you can get access to. Then, of course, a lot of source code is available in open source through our GitHub, Wirepas, so github.com/wirepas. There's also a lot of good documentation regarding how the gateway operates, how the MQTT server is architected, what are the APIs for the backend, etc. So there's quite a good amount of technical information there. Then, of course, from a technical support perspective, you can contact Sebastien. His address is here. If you want to engage with us or partner with Wirepas, my email is here, and of course, Ben Corrado, ben.corrado@wirepas.com is heading the Americas, and of course is fully available for the follow-up with you. With this, I want to thank you very much again for your participation, a very active participation to this webinar. It's been great having you. And we absolutely look forward to hearing more about your Wirepas Mesh projects, hopefully very, very soon. Thank you very much.